Something like a homie.
That's awesome. This is the Greek letter theta.
There we go.
There we go.
What is
This is the Greek letter alpha. This is the Greek letter beta. So anyway.
It looks like a little goldfish.
These are the lowercase symbols, I believe.
Oh, it's like a sock puppet.
I don't remember.
Sock I can see that.
It's like that.
Where's dinosaur? Those were cute. They were fun letters. Why don't we write like that?
If you take higher and higher level math, science, or engineering classes, they introduce more and more Greek symbols because they need more symbols to describe what's going on. So, yeah. Oh, good. This one's V, I think, is the.
And there's like the little E thing, epsilon, right?
Sigma, you know.
Omega looks like a horseshoe.
Omega, my bad, sorry. Sigma, this is capital Sigma, I think is the.
Something like that, yeah.
Okay, moving on. That was kind of boring.
Something we don't know.
That was good. That was.
Okay, we're back to limits. So we're back to September. Okay, the limit flashcard I reminded you of a lot in September. The limit flashcard is check and see if the limit is approaching infinity. It's not. If it were, we would try to compare terms that are adding. Second one, factor and divide. Can't do that. So third one was to check left and right limits. When we try that, here's what happens. I plug in close to 0. What is the cosine of a number close to 0?
1.
Close to 1. So the top becomes 1, subtract close to 1 or close to 0. Plug in 0 here, the sine of 0 is 0, so that number squared is close to 0. If you're checking left and right limits and you end up with 0 divided by 0, or infinity divided by infinity, it usually means, this one usually means you forgot to compare terms that we're adding. This one means you forgot to factor and divide. Or the problem requires a new rule known as L'Hopital's rule. It's funny how you all panic. If I'd said Frank's rule, you wouldn't have panicked.
That's
Triangle over as a 10.
Isn't that true? like you just have to overcome your fear of foreign names.
No, that means what's like the hospital. Probably where all these people are.
Hospital.
It does mean in French the hospital. So
Great.
Looks like I'm going there.
okay, look listen. It's like I warned you at the beginning of class. You don't let the words, the symbols all bother you. You just go, oh, there's just a rule. I just use the rule. Okay.
It's like when the rule is called the L'Hopital rule. I can't even pronounce that.
You did great. Do it again.
L'Hopital.
Perfect. L'Hopital.
Can we just like simplify the spelling, like L-O?
However you like. It doesn't matter to me. But okay, here's what you have to memorize though. Listen. Okay, so again, limit flashcard. You're going to check to see if the limit is approaching infinity. Second, factor and divide if you can. Third thing, you're checking left and right limits. If this is what you get, you're like, oh, I have a new tool now. I can use L'Hopital's rule to answer the question. You cannot use the rule unless this happens.
It doesn't have to be 0 over 0.
It has to be 0 over 0 or infinity over infinity.
Okay.
If there are positives and negatives involved, it doesn't matter. That's just whatever. But it has to be 0 over 0 or infinity over infinity. L'Hopital's rule says this, that if this is true, then the following is true. Again, it's only true. Theta can approach any number. It doesn't matter. And it doesn't have to be theta. It can be x. It can be h, whatever. L'Hopital discovered that the answer to this limit question is exactly the same as the answer to this limit question. questions? So what he said was, if you cannot find this limit, don't worry about it. It's just like, kind of like the fundamental theorem. If you can't find this limit, as long as this is true, like when you tried to find the limit, you got this, just go find this limit instead. You'll usually find it easier.
Just take the derivative of both the top and the bottom.
Yeah, so not the quotient rule. It's not the quotient rule at all. It's a
The
separate.
top and the derivative of the bottom.
It's way easier than the quotient rule.
That's
You're at the top, you're at the bottom. So I come over here, and I say, I need the derivative of 1 minus cosine of theta. Look, it's crucial you get the bottom right here. When using L'Hopital's rule, it's got to be d of whatever the limiting variable is. Theta. So this is equal to, let's see, the derivative of 1 is 0. The derivative of the cosine, there's a -1 multiplier. The derivative of the cosine is the negative sign. So I figured out that the derivative of the numerator is just sine of theta. Question? Now you find the derivative of the denominator. So I want d of 2 sine squared means this, sine of theta all squared. And this has to be d theta. Question? Just watching pencils, we don't want to go faster than you can write. So 2 is a multiplying constant, so I just write it down. Bring down the 2, multiply by sine of theta,
Should do power rules.
using the power rule. The new exponent is going to be 1, and then I'm going to multiply by the derivative of the sine of theta. Which is cosine theta. So now I have the derivative of the bottom is going to equal 4 sine theta cosine theta. Anyone want me to? Now you can factor divide. You don't really have factor, it's already factored, but
Yeah,
yeah.
the sine and the sine.
The signs are going to divide out. So does anybody need more help here? Then we'll do the step that Jackie said.
I was just wondering with the rule, does it also apply if it's A approaching theta?
Right, it doesn't really matter. It's
Okay,
just,
doesn't matter.
yeah, like if you look through some of the problems in the packet,
So it's like U sub, but not in a way.
I get what you're thinking, U sub, because in a sense, I see why you'd say that. Because you're saying, with U sub, we have this integral, and we do this transformation and say, well, we don't need to find this integral, we'll just find this one
And then
instead.
you pop it back in.
In that sense, it's like that. This one, there's no popping back in, because what L'Hopital discovered was, you need to find the value of this limit, don't even worry about it. You couldn't, we got stuck, so go find this limit instead. Once we find it, we're done.
Do you need to keep the A though?
A just depends on the problem. Like in this case, A is 0.
Yeah, exactly.
Yeah. Does that answer your question?
Yeah.
Good. What I was trying to answer a second ago is this. Like in this problem, the limiting variable is x. And so you're going to take the derivative in terms of x. But it's the same process. Question? Please.
Wondering, if you go back to wherever you were on, the limit of theta to 0, you have the derivative of sine of theta. And I wonder where that came from.
So I started with this.
So what of the bottom of it?
Right here. Oh, gotcha, my bad. So you're okay that right here we are taking the derivative of this denominator. So I've got 2 multiplied by sine of theta all squared. So the first rule I'm using in my head is that 2 is simply a multiplying constant. So I just wrote it down. Now I have to use the power rule, because I have something being squared. So bring down the 2, multiply by that same something to a new power, 2 minus 1. The last part of the power rule, if you look on your green sheet, is derivative of the something. Is that your question? Point? Okay, look. We have the derivative of the numerator, we have the derivative of the denominator. L'Hopital's rule says we need to create a new new limit problem. So I'm going to copy this over. And this part will erase. This is what Harrison was saying. We take that information and we create a new limit problem. This limit is equal to this limit. The limit as theta approaches 0, a was just for the formula, so we'll put a, of sine of theta divided by 4 sine theta cosine theta. And then as Jackie noted, this denominator is factored. So these factors can legally be divided to make 1. It's not equal to 1 if you are right at 0. It would be undefined. But as long as we're just close to theta equals 0, we're fine. It's going to equal exactly 1. Close to 0, the cosine is 1, so the answer to this problem is 1/4. If you took this formula and you plug in a number that's really close to 0, you'll find that the value of the formula is 1/4. That's all we're doing. Question? So that's L'Hopital's rule. So today we've really learned 2 new things. One, it is possible to find the value of an integral using geometry. And then we've also learned that you can use L'Hopital's rule to find the value of a limit in some cases. Next one. Oh, and we also learned the derivative of an integral. Sorry, I forgot about that. Those are the 3 main ideas for today.